Hey everybody, my name's Lee. Along with a couple of my co-workers, we work for the Minnesota Pollution Control Agency. We're going to talk to you about rivers, and we're going to show you a working river model. The really cool thing about a river model is that you can see things happen much faster than they would happen in the real world, and you can also see things that might happen in the middle of the night when you're sleeping. So before we show you the river model, though, I want to talk a little bit about a real river. I'm standing here next to the Blue Earth River. The Blue Earth River, just a little ways downstream of here, beyond those two bridges, the Blue Earth River joins the Minnesota River. The Minnesota River then flows on downstream to St. Paul, where it joins the Mississippi River. And I think you all know where the Mississippi River goes. The Blue Earth River flows into the Minnesota River by Mankato. It's actually right near my house. And I like to come down here a lot. I like to fish right at this spot we're standing right now. Sometimes I catch something. Got here. Got a fish on. Feels pretty, I don't know, feels little. Oh, let's see, what do we got here? Little channel catfish. Look at that. Got these sharp spines on its fin, but if you handle it carefully, you can work around those, try to unhook it, and get it back in the water here. There we go. This is also a really popular stretch of river for canoeing and kayaking. And sometimes, if it's a warm day, those people who are out canoeing and kayaking, they'll stop on a sandbar and have a swim in the river and enjoy themselves in that way. But the Blue Earth River, it has some problems. There are times when the river gets so high and the water's moving so fast that it does a lot of damage to the riverbanks. Like you can see over here, you can see some of the exposed tree roots and such where the river has eroded the banks. The river's also often really muddy. The look of the water is really muddy. You can see the color of the water, and you can also see down by my feet here the mud that I'm standing here. This is left over from when the water was higher just a few weeks ago, and then that water went down again and it left behind all this mud. So that high, fast water, the mud that's in the river, the mud that gets left behind, that creates some problems for the Blue Earth River. It makes it a place that's not so healthy for the fish and the insects and the other things that are trying to live, trying to make a living in the river. And it also makes it not so pleasant of a place for those people who are canoeing and kayaking, or like me, coming down to the river and fishing. So when we look at this, when we look at the river model here, maybe we'll learn a few things that'll help us figure out what's going on with the Blue Earth River and what we might do to make the Blue Earth River and other rivers a little bit healthier.
Welcome to our stream table. This table helps us see how rivers move and change through different weather and through time.
Our stream table is filled with little pieces of plastic that act like sand when we run water across and through it.
The first step of the scientific method is to observe. So we're going to observe some things about this stream. How it moves, how it changes, what happens when there's more water, what happens when there's less water. And we're going to use that power of observation. We're going to use our eyes and our ears. And if you were here with me, you would be able to use your smell too, and your sense of touch. Unfortunately, we don't get to use smell and touch. So just imagine yourself next to a river.
We are now going to observe the stream table for a short amount of time. Think about what you are observing and write it down or type it in a document if you wish to. One of the first things you may have observed is how the water is moving in the river. The movement of water in a river or stream is called flow. Water always flows from a higher point or elevation to a lower point or elevation. We also call this moving from upstream to downstream. Water naturally flows in an S shape in a river. This pattern is called meandering. When a stream meanders, you will have outside bends and inside bends. The amount of water, or flow, in a river changes often over the year and between years. When there isn't much water in a river, we call that low flow. Here you can see our stream table at low flow. There isn't much water moving through. When we get a lot of rain and more water enters the river, we call that high flow. Now you can see that the water is moving much faster in the stream table. Another observation is how the sand starts falling off the sides of the stream. The sides of the stream are called banks. The process of water wearing away the sand is called erosion. When it is on the sides of a river, we call it stream bank erosion.
Erosion is a process that can happen a lot of different places. It is the way water moves away sediment, and it happens in streams, and it also happens on trails. Here, we just got a big rain event last night, and the trail is washed away.
Here we see how the sand is moving with the water in the stream. Scientists call sand, dirt, gravel, and rocks sediment. You are seeing sediment floating or suspended in the flow of the stream. We call this dirt or sand in the stream suspended sediment. Sediment doesn't stay suspended in the water forever. Eventually it falls out or deposits when the water slows down and doesn't have enough energy to carry it anymore. You can see depositing sediment on the inside bends of rivers, where you might find a point bar, on sandbars in a river, or at the end of the river where it enters another body of water. The place where a river enters another river or another body of water is called a confluence. When a river enters a lake or ocean, you may see a delta being formed by deposition. One of the most famous deltas is at the end of the Mississippi River in the Gulf of Mexico. Here, we can see the sediment slowly building up toward the bottom of the screen. We will talk about some more river processes in a bit, but first, can you think of anything we are missing in our stream table that you usually see when you are standing next to a stream or river? You will very likely see trees, grass, and other plants. You may see rocks of all different sizes. There might be some trees that have fallen in the river, or logs and branches that are by the sides of the stream. I'm going to add some little tree branches, sticks, and rocks into our stream table to make it look a little more natural. Now we will observe the stream for another minute or so and see what we can see that is different from when we didn't have anything in the stream. Again, think about what you are observing and store those thoughts away in your brain or write or type them down quickly. When you look at some places in the stream, you may notice a stream process called scouring. This is another type of erosion. Scouring can happen on the bottom of the stream, also known as the stream bed. Scouring can also happen around rocks in the stream when water flows around the rocks and starts digging out a hole or pool right behind the rocks. We can also see pools on rivers on the outside bends made from scouring. This is one place fish like to hang out. Now let's talk about what happens around us on land when it rains. Some of the water will fall on hard surfaces like roofs, driveways, sidewalks, and roads. Water can't go through this surface and runs off. This is called an impervious surface. Some of the rainwater will also fall on the ground, which is a surface where water can soak in. This is called a pervious surface. If an impervious surface has pollution on it, like garbage, dirt, oil, or salt, and it is too close to the water, the rain can wash that pollution right into the stream. We can use nature to help us make sure that the rivers stay cleaner by planting trees, plants, and long grasses between the impervious surfaces and the river. This is called a buffer. You can see that instead of running right into the river, the pollution is now caught by the plants and trees.
Okay, so we know that we have water on the surface of the earth, but there's also another place we can find water. Now, when we look at this surface, we don't see anything right here, but Colin is going to dig a hole for me and see what we find at the bottom of the hole. Take a big scoop, a nice big scoop. Keep digging. What'd you find?
A bunch of water.
A bunch of water. This is called groundwater. Colin, can you dig it just a little bit deeper? Nice and big scoop.
There's even more water.
There is even more water. That's awesome.
Groundwater is important because that is what many of us drink. If you have a well at your house, you are drinking groundwater. Many cities also pump groundwater up into the water towers to send to our houses when we turn on the faucet. Other cities pump surface water into their water towers for drinking. We just learned that not all water is on the surface and that some of it is underground. That groundwater can move just like streams do. Water can also move from the ground to the surface and back into the ground. When water comes out of the ground in one spot, we call that a spring. Here you can see a spring in our stream table on the left side of the screen. Sometimes people and beavers build dams. Watch what happens in the stream table when a dam is built. The dam stops most of the water from going through to the other side. Behind the dam, the water starts to build up. This is called backwater. Our dam isn't very well built, so when the pressure of the backwater gets too big, then the dam breaks and everything rushes downstream. This can also happen in nature when we get really big rain events that make a lot of flow go down the river.
This little stream heads to a lake, and it's important for us to keep it clean so that others can swim in that lake, fish in the lake, and in some water bodies, we like to make sure that we have good drinking water from them. So this little stream is really important to protect, and you can get out and watch and learn and see what streams do all around where you live. Can you think of some ways that you could help our streams and rivers and keep them clean? Use a notepad or your computer to figure out and write down some ideas that you have about keeping our rivers clean, that you could do or your parents and family could do too. One way that you can be able to help keep our streams and rivers clean is by picking up the leaves and making sure that they get composted or get put into yard waste. The leaves add nutrients to our streams, and nutrients are a good thing, kind of like taking a vitamin. Some people take a vitamin every day, but you wouldn't want to take too many vitamins because that would make you sick. And same with too many leaves or too many nutrients to a river. That would make the river sick too and produce stuff that like algae, and that would harm the fish and bugs that live in the stream and river. Another thing that you can do to help the streams and rivers is by picking up trash and making sure it goes in the right spot, into the trash can. You might have a dog at home or have family that has a dog or friends. And one way you can help keep our rivers and streams clean is by picking up their dog poop. So Willow here made a mess and we're gonna pick it up. Thank you for joining us today. I hope you learned a lot from us, from Lee, from Eileen, and learned about how streams move and their processes. And I hope you learned what you can do to help keep rivers clean so that we can have them for fishing and for the bugs and fish that live inside of them, and so that you may get drinking water from them too. Thank you so much and have a wonderful day.